Hi, grade 6. This is a math video for chapter test 10, form 2C, which is the practice test. Number 1 says draw an angle having a measurement of 180 degrees and then classify the angle as acute, obtuse, right, or straight. And that somewhat relates also to numbers 2 and 3, where you're supposed to classify those as being acute, obtuse, right, or straight. Well, just as kind of a review, remember, acute angles are angles that are somewhere between 0 and 90 degrees. So for example, this right here would be an acute angle because it's approximately 25 to 30 degrees. 25 to 30 degrees would fit in that category. The next type of angle, obtuse. Obtuse angles are the ones that are between 90 degrees and 180 degrees. So for example, this would be an obtuse angle. If I measured it with a protractor, it'd be about 150 degrees. 150 fits in between 90 and 180 in this inequality. The next type would be the right triangle. Remember that right triangles always equal 90 degrees. So an example of a right triangle would be something like this, where the corner or the vertex looks kind of like the corner of a page. And finally, a straight angle is any angle that's exactly equal to 180 degrees. So for example, this would be an example of a straight angle. We would call it a straight line, but hopefully that helps you with 1 through 3 if you've forgotten how to run through some of that stuff. What about number 4? I'm going to do one similar to number 4. I'm not going to do the exact version of number 4. Instead of 6, 1, 1, and 4, I'm going to put 8, 2, 2, and how about 8 again? Why not? And we're talking about $1 bills, $5 bills, $10 bills, and $20 bills. And our goal is to figure out how to create a circle graph based on that data. And this is the number of bills in circulation in trillions of dollars. Okay, so this really represents 8 trillion, 2 trillion, 2 trillion, and 8 trillion. Well, the first thing I would do is I would add up all of those numbers. And I would get the number 20. And then I would say to myself, this 8 trillion right here, this 8 trillion right here, that really represents 8 out of the 20 trillion. And this represents 2 out of the 20 trillion. And this is also 2 out of the 20 trillion. And this is 8 out of the 20 trillion. Okay? Now, if I want to change this into a situation where it becomes sections of a pie graph, a circle graph, I'm going to change these all into decimal numbers, and then I'm going to multiply them by 360. The decimal values of these are pretty easy. It's just the top number divided by the bottom number. 8 divided by 20 is 0.4, and 2 divided by 20 is 0.1. I'm going to then take that 0.4 times 360, and the 0.1 times 360. And when we do that, we should get some values of degree measurements, because we're talking about 0.4 of an entire circle of 360 degrees. And that would be 144 in that case. It's also 144 here. And these two would be what? 36, I think. Yeah. So now, if I were to draw a circle graph, and I would create, I don't know, what, 36 degree angle, that would be about like that, and another 36 degree angle, that would be about that, and then there would be my 144 and my other 144. So this would be the value of $1, and this would be the value of $20 bills, and these would be the sectors for 5 and for 10. So basically, we added up these numbers to get a total amount, which was 20 trillion. And then we made fractions of that total amount turn them into decimals and multiply by 360 to come up with our decimal values, or excuse me, our degree measurements for our pi graph. Okay, let's go on to 5 and 6. 5's talking about something called vertical angles. I have two angles that look like this, and let's say this angle measures 80 degrees. Is there a way to figure out that value? And the answer is yes. Vertical angles in your book are described as two angles that are opposite of each other in regards to intersecting lines. And in this particular case, since this is 80, then this also has to be 80. Now, just for the fun of it, could we figure out these two as well? Sure. If this is 80, then these two angles have to equal a straight line, don't they? And so that would make this 100 degrees. Okay. How about number 6? Any idea how you'd handle that? Well, you notice how the bottom of number 6's picture is a straight line. If I created a ray like this and I called this 30 degrees, the rule says that this one has to be 150. Why? Because 30 plus 150 equals 180, or a straight line. 7 and 8, hopefully you remember how to do that. But if you don't, here we go. Here's an idea. If I tell you that this angle right here is 60, and I want to find this angle up here, well, I know that this is 60 and this is 90, so I'm going to add those two together, plus I'm going to add the x into it, and together the 3 should equal 180. And if I solve this, I'm going to end up with x equaling 30 degrees, because 30 plus 150 is 180. So x in this case has to be 30 degrees. 9 and 10, they're looking for a name like, is it best called a quadrilateral or a parallelogram or a rectangle or a square? Is it best called a trapezoid or a rhombus? Number 11, if we have a four-sided figure and we want to figure out a missing measurement, like let's say for example this is 70 degrees and this over here is 80 degrees and this we called x, and over here we'll call that 100 degrees. Is there a way to find x? Yes. Before with triangles we added up all the angles and we made them equal to 180. But this is not a triangle. This is a four-sided figure, so the number changed. We now say that they have to equal 360. If I add up these three numbers, I get 250 degrees. And what value of x would be true such that this plus x is this? Well, that would be 110 degrees. Because I just subtract 250 from both sides of the equation. Okay, let's go to the back side. Uh-oh. How do you determine if two figures are similar? Well, let's imagine we have these two triangles. And these two triangles have the following measurements: 4, 6, 2, 4. And somebody said, hey, are those similar triangles if we've got these measurements listed here? Well, the way I would do that is I would say to myself, let's look at the corresponding sides. And let's see if the corresponding sides form equivalent ratios. Do the corresponding sides form equivalent ratios? Is 6 over 4 the same thing as 4 over 2? I don't know. How do we figure that out? Well, there's a couple ways, but here's one. Let's use cross products. 6 times 2 is 12, and 4 times 4 is 16. I'm just taking and multiplying the cross products. These are not the same. Therefore, in this case, they are not similar. Right? Not similar. But what if I change this 4 to a 3? would that affect everything? Well, now it'd be 12 and 12, wouldn't it? The cross products equal 12 and 12, so now we would call them similar. So the method I used was I looked at the corresponding sides of each of the two shapes, and I asked myself, are the ratios of the corresponding sides equal? Let's go to 13. 13. What if I had two shapes that look like this and this? And I put an X here, and I put how about a 12 here, and a 10 here, and I put a 5 here, and over here I put how about a 5 here, and a 2.5 here. And we want to figure out what X is. Well, what is the corresponding side to X? I would say this 12 is, right? And what's the corresponding side to that 10? That'd be the 5. And for this 5, it would be this 2.5. Now, we're going to use the ratio we don't know, 12 over X, and we're going to use one of the other ratios. I'm going to use the 10 over 5 one. Okay, so 12 is to X as 10 is to 5. 12 is to X as 10 is to 5. 12 is to X as 10 is to 5. And then we solve. In this case, X is 6. So our X value here has to be 6 if the shapes are similar. Okay? 14 and 15. Don't forget these two formulas. The question is, which one do we use for 14 and 15? The directions say find the measure of an angle in each polygon. This is the one we use when we're trying to find out the measure of all of the angles in one particular polygon that has a certain amount of sides. This is the one we use when we want to figure out what one angle of that particular shape is going to have if it's a regular polygon. So let's say, for example, we were talking about a six-sided object like a hexagon. And let's imagine I was able to draw this hexagon exactly perfectly regular. I can't. But imagine that all six sides are the exact same length, which would mean that all six of the angles would be the same length. And we would call this a regular hexagon. A regular hexagon. Now, in the case of this situation, I would take 6 minus 2, and I'd multiply it by 180. And when I do that, I get an answer of 720 degrees. Now that number represents the adding up of all of the angles of the hexagon. All six angles, when added up, would equal that 720. But if I want to know the measurement of just one of the angles, I would do this, where n is the measure of sides, 6 sides, and in this case, the answer would be 120 degrees. In other words, each one of these angles would be 120 degrees. Now, which one of the formulas are we going to use for 14 and 15? You got to use this one. Okay, I think we'll stop at that point. Thank you.